So here's what we've got. I'm just going to draw out what our graph should look like. Actually, let me do a better job here. So this is going to be our theta axis, and this will be sine theta. We know that sine, I'll do it in yellow here, it's going to start out at 0. It's going to come up, back down, just like that. So this is going to look something just like that. And this is at pi over 2. And this is at pi. 3 pi over 2. And this guy over here is at 2 pi. And this is at 0. So I'm going to graph this out. And by the way, this is at a height of positive 1. And this is at a height of negative 1. So I want to do the same graph on my calculator. Well, if I want to graph the same thing out, this guy over here is called my x max, and this guy over here is my x minimum. So I want to graph between 0 and 2 pi. It's like saying we want our angle to be between 0 and 2 pi. So our x min and max. Now our y min and y max, those on the y-axis. So this guy right here is our y max. This guy right here is our y min. And now our scale, well, our scale on the x-axis, I'll do it in green, is I saw a dash every pi over 2. So this is on the x. And our scale on the y, I'm seeing a dash here every 1 unit. So when I grab my calculator, the first thing I want to do is figure out what my x-axis is going to be. Is it going to be radians or degrees? Now here I'm in radians, so I want to make sure that my mode is in radians, which it is. Now I'm going to go into my y equals, and I'm going to put sine x in there. So how did I do that, guys? Here's the sine key right here, and then here's your variable key. Now you might say, well, I wanted theta. Well, we don't use theta unless we're in polar, so we use x for this rectangular, so sine x. So sine x is the same as sine theta in this case. Now we're going to go to the window, which is right here, and I want from 0 for my x min, okay, right here, x min, to 2 pi, which is the x max. So I'll hit 2 times. Now you can either use the pi key, which is right here, or you can type in 3.14. My scale is going to be pi over 2. And the reason for that is because I want to dash every pi over 2. My y minimum is negative 1. My y max is positive 1. And our scale is just we want to dash every 1. Don't worry about the resolution. Hit graph, and there it is. And so this graph right here is exactly the same as this graph over here. Now we can do this with cosine. If I just change this to cosine x, hit graph, there's our cosine curve. So now go back and look up above and make sure your cosine curve looks like that. We can also graph tangent if we'd like. Okay, now this, if you leave the tangent, it doesn't look like I can see quite as much. So what I'm going to do is I'm going to change my window so I can look a little bit higher and lower. There we go. Okay, so you can see that I curve up like this over here, come up through here, and down like this. These vertical lines are asymptotes. They're not really part of the graph. Now, on some of these, you can go ahead and get rid of them. I think if I go to dots, it just puts the dots in there for me. Okay, but it took out those vertical asymptotes. Okay, so that's one way to do it. But anyway, you've got your graphs then of all the functions. There we go again, that's tangent. So again, sine, cosine. We can even graph them both at the same time if we want. There's sine, there's cosine. Okay, so you should play around with your calculator, work on changing the wind around and seeing what you can see.